Hi everyone, so this is video 1.6, and in this lesson we're learning about compositions of functions, or sometimes they're called composite functions, or same idea. So the composition of two functions is basically when you plug in one function in another one, okay? So one way to write it is with that little circle. So this is read as g of f of x. So as you can see, it's like plugging in f inside of g. And we kind of did this in the function lesson where we'd plug something in another equation, but usually we didn't think of it as a function then. So here we're just taking that function and putting it in another one. So you could go ahead and read the different things there about them, but the last two bullets is kind of the main point. So if it's g of f, that's plugging f into g, and if it's f of g, we're plugging g into f. Okay, so that example on the front, we're going to do that at the end. So let's take a look at our examples on the inside. So we have our three different functions at the top, f, g, and h, and then we have some various operations to do for them. Okay, so let's zoom in a little bit and start right on number 1. So for here, this says we're doing f of h of 6. So we're plugging in h of 6 into f. So first we have to figure out what do we get when we plug 6 into h, and then we'll take that answer and plug it into f. Okay, so it's like two parts. So h of 6 would be 6 plus 3 in the square root. So the square root of 9 is 3. So h of 6 is 3. So what are we doing with h of 6? We're plugging it into f. Okay, so that means f of h of 6 is f of 3, because h of 6 is just 3. And if we plug that into f, we have 4 minus 2 times 3, which equals 4 minus 6, so negative 2. So f of h of 6 is just equal to negative 2. And that's it for that. Okay, so I want you, well, we'll do one more together and then you can try. So we'll do number 3. Okay, so f of negative 5. So another way to think of that would be like f of negative 5. I tend to write the inside one like a little bit smaller so I can kind of like see what's getting put into the other one. So we're plugging in negative 5 into f, and then we're taking that answer and plugging it into f again. Okay, so f of negative 5 is equal to 4 minus 2 times negative 5. So 4 plus 10, so 14. So now we'll do f of 14, because we're plugging in this into here. So f of 14, 4 minus 2 times 14, so negative 24. And that's really it, okay? They can get more complicated, and we'll work on a couple of the bottom ones, but what I want you to do first is question 2 and 4 over on the right, so go ahead and try those, and then we'll go over the answers, and then we'll do some of the complicated ones. Pause your video and work on 2 and 4. Okay, so here's what we should have got. 2 root 2 and 7. So make sure you write down any questions you have and we'll go over them. So let's look at question number 5. It's kind of the same as what we just did, except there's more parts. So I wanted to do that one with you guys too. Okay, so just work your way out. So we have g of negative 1, and then h of that answer, and then f of that answer. So it's like 3 parts. So first we would do g of negative 1. So that would be 2 times negative 1 squared minus 3 times negative 1 plus 5. So 2 times 1 plus 3 plus 5. So 2 plus 3 plus 5 is 10. So now we'll do h of 10. So we're working her out. So the next one is h of what we get from here. So h of 10 will be the square root of 10 plus 3. So that's the square root of 13. So now f of the square root of 13 would be 4 minus 2 times the square root of 13, which is 4 minus 2 times the square root of 13, so that would be it. So just work your way out, and you have your parentheses. So plug in this to G, that to H, that to F. Okay? Okay, so let's look at 6. So for number 6, it's F of G. So we're plugging in G into the equation F. Okay? So that means F of G of X means I'm plugging in F of the function G, so that's 2x squared minus 3x plus 5. So I'm plugging this in all the x's of F. Okay, so that is equal to 4 minus 2 times what we plug in for x. So remember F was 4 minus 2x, so I replaced the x with what? The function G. Okay, so now we just need to clean it up. So 4 minus 4x squared plus 6x minus 10. Combine like terms and put it in the right order. So negative 4x squared plus 6x minus 6. Okay, very good. So we did F of G, so we plugged G into F. So for number 7, it says G of F. So do you think we're going to get the same answer? Hope you said no. So it makes a big difference which one you plug in, you know, the order that you're plugging in, and you can get completely different answers. So in G of F of X means we're going to plug in 4 minus 2x into the equation G. So that means we would have 2 times 4 minus 2x squared minus 3 times 4 minus 2x plus 5. Because the equation G was 2x squared minus 3x plus 5. So where those x's were, we replaced. So now we just need to simplify all that, FOIL it all out, and we'll be done. But this is definitely not the same answer we got from the other one. Okay, so from here we need to FOIL. So I'm not going to show you the math, I'm just going to do it. So we get 16 minus 16x plus 4x squared minus 12 plus 6x plus 5. So I'm going to distribute. So 32 minus 32x plus 8x squared. I have some like terms here. Minus 12 and plus 5 is minus 7 plus 6x. So now I'm going to combine like terms and put them in the right order. So we have 8x squared. So I took care of that one. Minus 32x plus 6 would be minus 26x. So I took care of those. And then plus 25. Okay, so as you can see, plugging in F of G or G of F make a big difference to your answers. So make sure you're paying attention to which function is nested inside the other ones. Okay, so let's take a look at our last one. It's another one like number 5. So G of F of G of 0. So it might help to write it out the other way. So G of F of G of 0. Okay, so we do this one, and that one, and then the whole thing. Okay, so it's like nested inside there. So the first thing we have is G of 0. So G of 0 is 2 times 0 squared minus 3 times 0 plus 5. So we get 5. So now we're taking that answer and plugging it into F. So F of 5 equals 4 minus 2 times 5. 4 minus 10 is negative 6. And now we're taking that answer and plugging it into G. So G of negative 6 equals 2 times negative 6 squared minus 3 times negative 6 plus 5. So exponents, 2 times 36 plus 18 plus 5. So that would be 72 plus 18 plus 5, which is 95. So our final answer would be 95. Awesome job. So let's take a look at the front again. one thing I thought of while we were working that I wanted to point out is that, just kidding, next lesson, not this lesson, nothing to point out. So let's do this example. So this is like a real world application of why we would have this. So it says that we find out that our favorite store, which is called Cool Clothes, is having a 20% off sale. And we have a coupon that's worth $5 off any item. So we have two different discounts that we can have. Okay. So I'm going to say that F is going to be the coupon, or I'm sorry, the 20% off, and G is going to be the coupon. So we want to write a function to model it. So 20% off is like subtracting 0.2 of our total, right? Because 20% is 0.2. So if our total is X, 20% off would be subtracting 0.2 of our total. So that's like paying 0.8 or 80% of the cost. So this equation was for modeling the 20% off. Okay, so our another one is for the $5 coupon. So with a $5 coupon, we just take $5 off of whatever our total. So it'd be the total minus 5. So there's our two functions. 20% off, $5 off. So it says write a function to model if the salesperson applies the 20% off first. So that means we're doing the 20% off first, so that's nested in the other function. Okay, so that would be saying G of F of X, because F is the 20% off. So 20% off first, and then the coupon. So that would be like G of 0.8x. So if we plug that in, 0.8x into G, we'd have 0.8x minus 5. So if I do the 20% off first, and then I take off $5. So for C, it says, what if we take the $5 off first? So then we would do F of G of X. So we do function G first. So that means we're plugging in X minus 5 into our function F. So we'd have 0.8 times X minus 5. And if we distribute, we have 0.8X minus 4. So which one would you rather have? 20% off first or $5 off first? I hope you said this one, because 20% off first, you're getting 20% off total, and then you're still getting your $5 off. Here, if we do the $5 off first, you're losing $1, which is really what the other question asks you. How much more is any item if the clerk applies the coupon first? Well, you'd be paying $1 more, because it's only minusing 4 instead of minusing 5. But mathematically, we can subtract these and see the difference on how much. So if we do F of G of X minus G of F of X, we can see the difference. So that would be 0.8x minus 4 minus 0.8x minus 5. So the 8x's cancel, and then we have minus 4 minus negative 5, so we get 1. So like we said, it's $1 more. So no matter what we bought, any item is $1 more expensive. Okay, so we want that 20% off first. So good life lesson there. Percent off first. Okay, and that's it for 1.6. Werner out.